In our last two examples, we were looking at an integral that was the product of a power function or monomial x2 and exponent times a function that, well, in both cases they were in e to the x, but a function that whether you differentiate it or integrate it doesn't go away. Okay, and we said that in those cases, when we're making our choice of u and v for integration by parts, u and dv, excuse me, we wanted to choose the monomial to be our u and put everything else in the dv. Well, here we have a monomial times a natural log function, and we haven't learned how to integrate the natural log function yet. Turns out you actually have to use integration by parts to do it. So since I can't integrate natural log of x, we're gonna have to put that into our u, which you'll see it's not gonna be too bad. And then I'm gonna put everything else in my dv, so x to the fourth dx. So we know that the derivative of natural log of x is 1 over x. So our, not dx, our du is just dx over x, or 1 over x dx if you prefer. And then to integrate x to the fourth dx, I'm just going to apply my power rule for integrals, and so I get that v is equal to 1/5 x to the fifth. I'll write that 5 a little bit neater. So then applying my integration by parts formula, the integral of u dv is equal to u times v. So natural log of x times 1/5 x to the fifth minus the integral of v du, so minus the integral of 1/5 x to the fifth times 1 over x dx, which I'm going to write as 1/5 x to the fifth natural log of x. Typically we'll write stuff to the left of a log or a trig function so that it doesn't look like it's inside the function. And then I'm going to simplify this. So x to the fifth divided by x is x to the fourth. So we're just integrating here 1/5 x to the fourth, which is a super easy integral. So we have 1/5 x to the fifth natural log of x minus power rule for integrals says x to the fourth is going to become x to the fifth. Divide by 5 and multiply by that 1/5 constant gives us 1/25 x to the fifth, and then this is where I add plus c. I'm going to go ahead and do another example. This time something a little bit different. I'm going to integrate 4 arc cosine of x dx. Okay, so I know none of my regular techniques work because we don't know how to integrate arc cosine x just yet. This is how we do it. And so let's do an integration by parts. Well, again, since I don't know how to integrate arc cosine, that's going to have to be my u. So I'm going to choose arc cosine x to be my u, and then my dv is everything I'm left with, so 4 dx. All right, so hopefully we remember the derivative of arc cosine x. Here's the differential of arc cosine x, but that's -1 over the square root of 1 minus x squared dx. And then the integral of 4 dx gives me that my v is 4x. All right, so then applying my integration by parts formula, integral of u dv is equal to u times v. I'm just going to go ahead and write that as 4x arc cosine x minus the integral of v du. So we're looking at negative, I'm just going to write negative 4x in the numerator over the square root of 1 minus x squared dx. And I just always want to be really careful when I'm doing integration by parts that I don't mess up my negative signs, because that's a really, really common mistake. And so before I even try to mess with this integral anymore, I want to simplify those negatives. So I'm going to write this as 4x arc cosine x plus the integral of 4x over the square root of 1 minus x squared dx. So now we need to just focus on this integral, and we'll just do a simple u substitution here. So I'm going to let u be 1 minus x squared, and so du is equal to negative 2x dx. We have 4x dx, so I'm going to multiply both sides by negative 2. So negative 2 du is equal to 4x dx. And so then what we're looking at for our integral is 4x arc cosine x. I can write this as, I guess, just minus the integral of 2 du, or actually, I'll leave it like this. All right, plus the integral of negative 2 du over the square root of u, and I'll rewrite it on the next line. So 4x arc cosine x minus the integral. If I have 1 over the square root of u, I just want to think about that as u to the negative 1/2. Super easy to integrate now, just using our power rule. And so if I add 1 to negative 1/2, I get 1/2. And so we're looking at 2 divided by 1/2, which is 4, times u to the 1/2, which is the square root, and I'm just going to go ahead and substitute back in my u, which is 1 minus x squared, and I'm going to add my plus c. And if I skip too many steps going from here to here, see if you can fill them in on your own.